So folks, now that we have done some synthetic division, we're going to learn today about the remainder theorem, and we're going to learn about the factor theorem. The first thing up is the remainder theorem, and we've actually been doing this all along. I just haven't told you it's been the remainder theorem. But the idea is this: if we divide a polynomial f of x by x minus c, and I know this is kind of abstract here, but the important part is whatever you get for the remainder, that's the value of the function. That's your output. And we've actually been doing that. I just haven't called it the remainder theorem to you guys. So again, in other words, the remainder is equal to the value of the function. So let's take this function here, f of x equals 3x cubed minus 2x plus 10, and we're going to find out what the value of the function when x equals 8. In other words, we're going to find f of 8. So what I could do is I can put 8 into my function here. I can cube 8 if I knew what that was. I can multiply it by 3, subtract 2 times 8, add 10. I can get that value. And that's fine, but that might, just because of this 3x squared out here, 3x cubed, that might get pretty big. I might not be able to do that so well. So I'm going to do synthetic division. So I'm going to pull my 8 out here. And remember, I'm going to put my coefficients, my 0x squared, my minus 2x, my plus 10, and my top line here. I'm going to leave a little space. And I'm going to do the synthetic division, or the synthetic substitution, actually, process here. So I'm going to bring down the 3. I'm going to do 8 times 3 is 24. Add down again. 8 times 24 is 192. Add down. 8 times 190 is 1,520. And again, add down. So, and again, we've done this before. We just haven't called this the remainder theorem. But this 1,530, that is f of 8. That is the value of the function of f when x equals 8. So it's kind of nice. We've been really kind of using this theorem as we've been going along here. Okay, so this is helpful because this leads directly to, as the words say on the page, the factor theorem. So we're going to do our synthetic division. What happens when a remainder is 0? So when the value of the function is 0, that means that the factor that we started with, or the expression that we started with, is actually a factor of the original function. So this is a way to help us to factor these polynomials, particularly ones that are a little less nice to work with. Okay, so we're going to determine whether or not x minus 3 is a factor of this larger polynomial, x cubed minus x squared minus x minus 15. Notice here how there's 4 terms. I might want to try to factor this by grouping, but if you remember what we talked about with the coefficients, this one's not going to be able to group. So we're not going to be able to factor this, but it might still be true that x minus 3 is a factor. So let's do some synthetic substitution, and we're going to find out here. So I'm going to set x equals 3 to 0, and I'm going to get x minus 3 equal to 0, and I'm going to get x equals 3, and then here are my coefficients for my polynomial, and I'm going to do the process. Again, bring down the 1, multiply 3 by 1, and put that there, and I'm just going to put the numbers up here, because hopefully at this time, you really should be comfortable with this process. But the good news is, our remainder is 0. So our remainder is 0, so that's telling us that x minus 3 is a factor. So pretty neat stuff that gives us that information. As it turns out, here's the cool part here. These numbers here tell us what another factor is. And this tells us, oops, went a little too far there, tells us that x squared plus 2x plus 5 is also a factor. And if we so desired, we can set that equal to 0 and solve it and find the actual remaining zeros of this function. I'm going to leave that to a later exercise, but we definitely could do that. Okay, so here's the one I inadvertently jumped to a little too quickly here. We're going to find all the zeros of this function here. And I'm going to tell us that negative 3 is a 0. So here's one of my favorite cartoon characters, Ralph Wiggum here, asking what a 0 is. So if you don't know what a 0 is a value that when you put it into your function, your output is, guess what? 0. Okay, so really, quite simply, we're just going to evaluate the function at x equals negative 3. That's really all that we're doing here. So, but once we do that, we're going to need to find all the other zeros. So I'm going to do this one by hand. And I'm going to put negative 3 out here. And I'm going to put in my coefficients. I'm going to try to do this properly. So I'm going to have 2x cubed, 0x squared, 11x squared, 18x plus 9. And by the way, I already know what my remainder is going to be, right? Because negative 3 is a 0, so I better get a 0 down here. Let's make sure that this is going to happen for us. So I'm going to bring down the 2. Negative 3 times 2 is negative 6. Again, add down. Multiply again. Negative 3 times 5 is negative 15. Add down. Multiply. I get negative 9 here. And certainly, or sure enough, I do get, when I add down there, 9 minus 9, I get 0. So again, here's the neat thing about this. These numbers here tell me what the other factor is. So 2x squared plus 5x plus 3 is another factor. So I'm going to set that equal to 0, and I'm going to go ahead and solve that. Now, as it turns out, this is actually factorable. So I'm going to go ahead and factor this, and this is going to have to be 2x and 1x, and I think this is going to have to be plus 1 and plus 3. So I'm going to just do a quick check here with my outers and inners. I get 2x and 3x gives me 5x, which is what I was looking for up there. So then I'm going to solve these individually. 2x plus 3 equals 0. 2x equals negative 3. Or x equals negative 3 halves. And from the second one here, I get x plus 1 equals 0. Or x equals negative 1. So I confirmed that negative 3 was a 0. And then from that, I actually got the other two zeros. I didn't have to do really much factoring. I guess I have a little bit down here at this line. But really, as far as new stuff goes, it's really this synthetic substitution, this synthetic division, and what it does for us, it gives us the other factor, right? It gave us that right there. Okay, so between these videos in this section, these are the things that we said we were going to do, and let's see if we actually did them. Are you able to divide polynomials using long division or synthetic division, or both, actually? Hopefully you feel a little more comfortable with that. You know how to do that. You should also be able to apply the remainder theorem and the factor theorem, and that's what we got into in this video here. So hopefully the remainder theorem and the factor theorem are a little more accessible to you as well. Thanks again, and I'll see you guys in class.